Good evening, all. Anyone having any doubts from question banks of application of derivatives? Am I audible? Can you hear me?
Yes, sir.
All right. So, do you have any doubts from question bank, or should I proceed with integration? Let me know. So, if you are not having any doubt, then I'll start with the integration only. Okay, yeah, one more thing before I take this class. Actually, in timetable, there is a class scheduled for tomorrow, right? Saturday. But tomorrow I won't be available as I'll be traveling. So that class I'll be taking on Sunday. And after the test, I'll be taking that class. Okay. So I'll inform you about the timings tomorrow only. But tomorrow there is no class. Okay. Keep that in mind. So now that we have completed elementary integration. So the next topic is methods of integration. That means those type of questions which cannot be solved directly or are not directly based on formulae, how they can be solved? They can be solved by the following three techniques. Either we'll be using substitution. See, in a general way, what is the meaning of substitution? There will be some function, we'll be equating it or letting it equal to t or something, some new variable. Okay. And with the help of that substitution, we will try to change it in a form or in a formula which can be integrated. Okay. So no theory for substitution as such, though I'll be just taking some types. But the general idea behind substitution is that we assume some function as t, and by help of that substitution, we try to change the question in a form which is integrable or which is related to the standard formula. Second one is integration by parts, which is the product rule also. And third one is partial fraction, integration by partial fraction. Okay. So today we are going to discuss the first type, and this topic is very wide. It is not just only of one class or something. There are so many types within this topic, that is integration by substitution. So some part we will be covering initially, and then we will learn about product rule or integration by part and partial fraction, and after that the remaining portion of integration by substitution will be covered at the end of the chapter. Okay. So let us straight away start with the type integration by substitution. So basically, if you face such type of questions where you have the function or integrand either of this type or of this type, suppose you have any of the two types, either fx please just confirm for a second. Am I audible? Am I audible to you?
Yes, sir.
All right. Actually, I thought I got disconnected. All right. So what I am saying, we are covering integration by substitution, and I'm taking this general type where you have this function fx. It may have some power, and with this you have its derivative also present in the same question. So in both of these, how you will proceed? You will proceed by taking fx as t. Okay, you will proceed by taking fx as t, and one more step you will do in the question, that is differentiate both sides with respect to t. What will happen as a result? Differentiation of f is f dash x, differentiation of x is dx by dt. You are using chain rule here, right? And now f dash x dx is dt. So based on these two, you can put these values here as well as here, and you will see that the question will change in a form which is integrable by substitution, sorry, by some standard formula. Okay, you have to observe that a function and its derivative are present in the same question. Such type of questions will be solved by substitution. Let me take an example that will help you understand in a better way. Suppose I have this question 2x upon 1 plus x square. Suppose I have this question, I want to integrate it. Okay. Now, as I told you, you need to look out for a function and its derivative. Function you are supposed to put equal to t, and then its derivative will be adjusted with this formula and it will change to dt or some term of t. Based on that, can anyone tell me that what is the substitution you are going to use here in this question? Can anyone tell what you are going to put in terms of new variable? Which term you will be considering as fx and putting it equal to t?
So 1 plus x square.
Yes, correct. So you will start by putting 1 plus x square as t. You will differentiate both sides with respect to t. Differentiation of 1 is 0. Differentiation of x square is 2x. Then differentiation of x is dx by dt, and differentiation of t is 1. So 2x dx is dt. Now after doing this, we will get the answer in the next step. In the numerator it is dt, 2x dx, and the denominator it is t. Now what I was saying, when you will use these substitutions, you will reach a form which will be comparable to the standard formula. This we covered in the last class. It is comparable to second formula, 1 upon x dx. So what will be the answer? Answer will be ln t. But question was in terms of x, so what you will do? Now in place of t you will put x. Sorry, you will, in place of t you will put whatever you have substituted. That is 1 plus x square. So that is the answer. Okay. In this way you will integrate. Then this is second question. So you just need to identify that what is that term or function that you need to put equal to t. Rest it will be solved very easily. What about this question? What you are going to suppose? Anyone? Yes, come on. What is the substitution here? Any one of you? Try it. What is the problem? It is easy. No idea. In this you put ln x as t. Why we are putting ln x as t? You differentiate it with respect to t first. Differentiation of ln x is 1 by x. Then differentiation of x is dx upon dt. In the right side it will be 1 because you are differentiating with respect to t. Now dt can be taken to the right hand side. Why I can shift like dt and dx here and there? Because if you remember, first derivative can be treated as fraction. I told you this. Do the substitutions, you will get the answer in the next step. In place of ln x, you put t, and in place of dx by x, you put dt. So what is your answer? Comparable to first formula. So what is actually happening in these questions? Initially, they were not comparable with any formula. Then you did some substitution. After doing substitution and changing in terms of new variable, you saw that now you can apply those elementary integrations. Once you solve it in terms of t, you can do whatever substitution you have done. You can put the value back again and you will get the answer. Okay. So based on these examples, now I am giving some questions. You will try them and then we will discuss them one by one. So we will not take the answer of every question. First you will try all of them and then we will discuss them one by one. It will take some time, so you try them first. Don't sit idly. Take a rough notebook and start solving these questions and see if you can get the answer. First, we will try these 4 questions. Okay, try them based on substitutions. Yes, what about the first question? Third one. Can anyone tell what will be the substitution?
So tan inverse x is equal to t.
Yes, good. Put tan inverse x is equal to t. Therefore, we differentiate. Now remember this step. After we put it equal to t, you need to differentiate also. Okay, because you need this value, right? You cannot work with x and t in the same question. Either you will be dealing completely in terms of t or completely in terms of x. So you are differentiating with respect to t. Remember this. We always differentiate with respect to the assumed variable. So differentiation of tan inverse x is this. Then differentiation of x dx by dt. Then this is 1. So dx upon 1 plus x square is dt. So this will become t dt. In place of tan inverse x, we put t and rest is changed to dt. So this is t square by 2 plus c. In place of t, we put tan inverse x. So this will be the answer. Tan inverse x whole square by 2 plus c. Third question. What about the next question? Can anyone tell me what will be the substitution for the fourth one? This is a good question. Fourth one. See, fourth one, let me tell you. In fourth one, we put the whole expression in the numerator as t. This thing. Important is differentiation part. Then you will come to know what is the advantage of taking this whole term as t. Let us differentiate with respect to t. So first thing is differentiation. So first we will differentiate log. Obviously we are going to use chain rule. We differentiate log. Then we differentiate the term inside the bracket. So differentiation of x is 1. Yeah. Or you can write dx by dt. Or what you can write dx by dt later. What I want to say, we differentiated log. Now we will differentiate the term in the bracket. So differentiation of x is 1. Differentiation of root is 1 by 2 root. Differentiation of 1 plus x square is 2x. And differentiation of x is dx by dt. And differentiation of t is 1. This gets cancelled. 1 upon x plus under root 1 plus x square into root of 1 plus x square plus x upon under root 1 plus x square dx equals dt. This gets cancelled. So dx by under root 1 plus x square is dt. We need to substitute values of these two in the question and that will be your answer. So it will change to, in place of this log of whole thing, this will be t and dx upon under root is dt. So once again you will use the first formula and you will write t square by 2 plus c. In place of t, we will write log of base c x plus under root 1 plus x square plus c. This will be the answer. I hope you have understood. So basically what we are doing in all these questions, we are assuming something as t, rest is changing into dt with some terms of t as well. Okay. Finally, after changing everything in terms of t, we are integrating by the help of formulae studied yesterday. And then once we integrate, we put the value of t back in the question and then you will get the final answer. Now what about the fifth question? Fifth one. Actually, fifth and sixth are interrelated, but sixth we will talk about later. What about the fifth question? Any idea about the fifth question? What should be the substitution?
So cos x minus sin x.
Very good. We will assume the denominator as t. See, so the actually what is the task? What is the problem? You just need to identify the function which will be equal to t. Only that's it. There is nothing else in the question. Okay, just need to identify the function. So cos x minus sin x is equal to t. And let me tell you something. For this integration part, you must do NCRT. Must do. Okay. It will be of will solve two purposes. First of all, it will help you prepare for the board exams. Okay, you will be covering this unit only during these days only. And secondly, it will help you to solve the questions based on JEE main pattern or whatever. Okay, NCRT for integration is good. You can solve each and every question. So if we put cos x minus sin x as t and we differentiate with respect to t, we differentiate cos. Cos is minus sin x. Then we differentiate x, which is dx by dt. Then we differentiate sin, which is cos. Then we differentiate x, which is dx by dt. This is one. So sometimes what I will do, I will not write dx by dt with every term. What I will do? What is the alternate way to write? Differentiate cos minus sin x minus cos x, and then I will make a bracket, and finally I will write into dx by dt. So I won't write this step, I will directly write this step. But ultimately what I am doing, I am differentiating and using chain rule. Okay. So either way, you should be able to understand that how I am writing those steps. What else you can do? You can multiply both sides by minus 1. Multiply both sides by minus 1. And finally, shift dt to the right hand side. Let us do the substitution. Cos x plus sin x dx. In place of this, we will write minus dt. In denominator, we write t. Once again, it changes to second formula. Answer will be minus ln t plus c. Put the value of t here. It will be ln of cos x minus sin x. This is the answer. Okay. Now let us solve the sixth one. 1 upon 1 plus pot plus 1 upon 1 plus pot x. In this question, you may not be able to solve the question by substitution directly. Because what you will do, put cot x equal to t, it won't help you. So let me tell you what are the steps. First, you change this whole question in cos and sin. This question is important, okay? Remember this question 6. It is an NCRT also. But some steps are to be remembered, okay? You cannot just directly think like that, okay? You need to solve such type of question once and then only you will be able to solve. So after changing in terms of cos and sin, you will take the LCM and it will change to sin upon sin plus cos. The problem comes after this. Till here it is simple trigonometry. What is integration here? So now comes the actual part of integrating, where you multiply and divide this whole expression by 2. And constant in division can be taken out because the property of kfx. Now in place of 2 sin x, there is a different way of writing 2 sin x. I can write it like this. Right? Only 2 sin x is written in the numerator. But now why we have written it like this? So that we can split it in two parts and we can solve it. Sin x plus cos x upon sin x plus cos x is 1. The next part is sin minus cos upon sin plus cos. Now we will split it in two parts. First part is easy. Integration of 1, everybody knows. Second part, now just like the previous question, Or if you want to change it in the same question, you can take minus common, so it will change to previous question. But there will be no previous question in the paper, right? So what you will do? You will put sin x plus cos x as t. Differentiation of sin is cos, differentiation of cos is minus sin. This is dx by dt equals 1. Dx by dt equals 1. So finally cos minus sin dx is dt. So in place of numerator, in numerator we can see we have sin minus cos dx. Sin minus cos dx, here we have cos minus sin dx. So what we are going to use? In place of dt, I will write minus dt. Reason is obvious. Cos minus sin dx is dt and sin minus cos dx will be minus dt. In place of t, sin x plus cos x we have t. Then integration of 1 by t is ln t. Finally, in place of t, you can put sin plus cos. What are these steps involved? First thing, change in terms of sin and cos, take the LCM, everything, then multiply and divide by 2. Then in place of 2 sin x, we can write sin plus sin. We add cos x from our side and we'll have to subtract also. Then we split the question in two parts. One part is one only, we can integrate it. Second part, put denominator equal to t. The numerator will also change in terms of t like this. Okay, it will change to minus dt. And then you can solve it using the standard formula. Well, this is clear to you. There is one more question. Try this. Then we will add some formula now. After this question, we'll add some formula. Solve this one. E to the power 2x plus 1 upon e to the power 2x minus 1 dx. Yes, anyone? Any idea about this question or the substitution? See, this question also cannot be solved directly. First step is divide numerator. So there are some questions which you need to at least solve once as example, and then only we'll be able to solve it again. So divide numerator and denominator by e to the power x first. So if we divide numerator and denominator by e to the power x, then by division we should actually separate it first. E to the power 2x upon e to the power x will be e to the power x. 1 upon e to the power x will be e to the power minus x. In the denominator, e to the power 2x upon e to the power x will be e to the power x. And 1 upon e to the power x will be e to the power minus x. Once you change it like this, now let e to the power x minus e to the power x is equal to t. See, this question is also in NCERT. So, obviously it can come in board exams. Otherwise also it's a good question, because generally it does not click that we have to divide numerator and denominator by this term. That is why. Now next step is always differentiating. So e to the power x dx by dt. Then minus is already there. So differentiation of minus x will be minus dx by dt equals 1. E to the power x dx by dt plus e to the power minus x dx by dt is equal to 1. You take dx by dt common. E to the power x plus e to the power minus x dx is dt. These two, let us integrate. In the numerator, once again you can see you will get dt. That is e to the power x plus e to the power minus x dx. In the denominator you have t. What you observed? Either question is changing in first formula or second formula. Once again ln t plus c. So some things have to be observed, okay? Either I am simplifying such type of questions, either they change in the form of x to the power n, or they are changing in the form of 1 upon t, and I am using formula of log because of the substitution here, okay? So this is the way to solve this question. Now after this, based on substitution, now that we have learned substitution, I am going to add some formulae. See, I have shared one PDF and all of these things are there in the notes, okay? Your first PDF, it is having material which will be covered till today's class, okay? So you can go through the notes and same examples are there. Now differentiation of 10x. I will write the result here. See, in some books there is mod with cos, and in some books it is simply log cos x plus c. I told you in the previous class also, both are fine. Either minus log cos x plus c or log mod cos x. In indefinite integration it is really fine. It doesn't matter whether it is mod or not, because it is understood that log is defined for positive values only. However, when definite integration comes, the next topic, then you always use the formula with mod. Whenever log is there, you put a mod with it. Okay, just remember this. Integration of cot x is log mod sin x or log sin x plus c, whatever. Sec x integration. You remember these four trigonometric formulae were not there in the previous class. Why? Because their proofs are given with the help of substitution. So they do not actually come in the form of elementary integration. We learn substitution first and then we use their formulae after proving them. Integration of sec x. We have three formulae here. Or at least remember these two. Two will be okay. See, in objective type of questions, they mainly use the second form, ln mod of 10 pi by 4 plus x by 2. Though both of them represent the same, trigonometry is used and you can convert sec plus 10 to this, okay? But When you will be solving objective type of question, this second form is more prevalent in options, this x by 2 type form. Then for third one, minus ln cosec plus cot plus c, ln mod cosec minus cot plus c, or ln mod tan x by 2 plus c. These three. Let me prove some of them. I will solve two of these, okay? Out of four, I will solve two. You can find their proofs in NCRT also, but for your understanding, I will be giving you proof of these four questions. See, if in a school exam, I don't know what is the mark distribution, but generally, this question can be asked in two type of marks, either 1 mark. If this question, these type of formula are asked, and for 1 mark, you are supposed to write the answer only. Integration of cot log sin x plus c. But if the same question is asked that you have to integrate cot x, and it is asked in 3 marks or 4 marks, then basically proof is expected there. Okay. So depending on the mark distribution, you will attempt the question in board exams. So suppose you have to integrate cot x. So what I am going to do, I will change it in terms of sin and cos. And here I am going to use the substitution. Very easy to observe that I will put sin x as t. As a result, I will differentiate in the next step. Differentiation of sin is cos, differentiation of x is dx by dt, and it will be 1 here. So cos x dx is dt. Now I will put these values dt upon t. This comes out to be ln t once again. And here only I said that sometimes I use t, sometimes I will use mod. Okay, both are fine here, but in definite integration you use mod always with ln. So ln mod of t, what is t here? This is sin. So ln mod sin x plus c, and this is only what is written here. You all of you know that log with base e means ln natural log, right? So that is why ln is written here. Now I will solve the next formula, that is integration of sec x. Integration of sec x. Now there will be no purpose if you write sec x as 1 by cos x. Okay. If you write sec x as 1 by cos x, it will be of no use. What you will do? Put cos x equal to t, but its derivative sin x is not present. So instead of this question is a little bit tricky. So remember this step. First you have to multiply and divide by sec x plus tan x. This is the step. Okay. First step. Now after this, I will put the numerator denominator as t. Okay. I'll put sec x plus tan x as t. After putting this as t, I will differentiate. Okay. Now you might be understanding what is the pattern, how to solve such type of questions. So integration of sec is sec x into tan x dx by dt. Integration of tan x is sec square x dx by dt. And here it is 1. We take dx by dt common, so sec x tan x plus sec square x is dx by dt. This is 1. We take sec x common. What you will get? Tan x plus sec x or sec x plus tan x. Dx. Dt will be shifted to the right hand side. And this is your numerator. This is your denominator. Once again, question changes to second formula. What is the answer? ln mod t. What you will write here? In place of t, you will write sec plus 10. See, first formula is coming. ln mod sec x plus 10x. See, this is coming. This one. First formula. Now using trigonometry, you can change it to 10 pi by 4 plus x by 2. This is no integration. This is trigonometry. How you will change? Sec is 1 by cos. This is sin by cos. Then just a minute. This will become 1 plus sin x by cos x. And here, after using trigonometry, you'll be able to write it 10 pi by 4 plus x by 2. How? What is 1 plus sin x? It can be written as cos x by 2 plus sin x by 2 whole square. Why? Because cos square plus sin square is 1 and 2 cos a sin is sin 2a. So it will become sin x. In the denominator, you will use formula of cos 2a. As a result, now one of the factors will be cancelled. Cos x by 2 plus sin x by 2 will be cancelled from numerator and denominator. Now last step. In the last step, you will divide numerator and denominator by cos x by 2. When you will divide it by cos x by 2, it will change like this. It will change in terms of 10. And this is formula of 10a plus b, where a is pi by 4, b is x by 2. If you use formula of 10a plus b, you will get this result. So in this way, we can change it in second formula as well. Proofs are important, especially of these four. Alright. However, application is more important. So just remember all these formulas. They are there in the PDF. You need not to write, though you may require here to practice the questions, but otherwise everything is written very well. So you just need to go through the notes once and you will be able to revise easily. So now we will be solving some questions. Let us see how you will solve. Ten x, 10 2x, 10 3x. So your first question. Then this is sin x upon sin x minus alpha. Then 1 minus sin x upon 1 minus cos x. You can start trying them. Okay. Let us solve these 5 questions. You try them once, then I will solve. Anyone having any idea about the first question? You can't split it, okay? You can't change it in 3 integrands. But with trigonometry, with the help of trigonometry, you can change it in some integrable form. And that is, since 3x is equal to 2x plus x, this is basic maths, everybody knows this thing. So if we apply 10 both sides, and use formula of 10a plus b in the right hand side, it will become 10a plus 10b upon 1 minus 10b. Now let us cross multiply. With 10 3x we will multiply 1 minus 10 2x 10x, and here it is 10 2x plus 10x. This becomes 10 3x minus 10 3x 10 2x 10x. In the right hand side it is 10 2x plus 10x. Let us shift the two terms on the left hand side, and this term in the product form on the right hand side. So basically this is question of trigonometry rather than integration, because integration will take only one step. Instead of this we can use this result, okay, because of trigonometry from year to year. You might have solved this question in class 11th also. So now that we have proved that this product can be written like this, so that means using this concept I will write it like this, and now we have minus in between, so it can split in three integrands, right? One important thing is the rule studied last day. Integration of 10, we just discussed, it is log sec x, okay, log mod sec 3x plus c. But what about 3? Why 3 in the denominator? Because if the integrand is comparable to some formula, but coefficient of x also comes in place of 1, there is some number, then integrate like that only, but divide the whole integrand, that integral, by the coefficient of x, okay, don't write c. Then 10 2x is also there, so it will be log mod sec 2x by 2. Then 10x is also there, so minus log mod sec x plus c. One important thing, do not write c with every integral. Like you integrate 10 3x, you write a constant c. You integrate 10 2x, you write a constant say d. You integrate 10x, you write a constant say e. But what is the purpose of writing c and d and e? Ultimately their sum will be a single constant. Like 3 plus 4 plus 5, it is a single constant. 12. Similarly, c plus d plus f, it will be changed to a single constant. So that is why when the whole thing is integrated, we use integration only one time. Sorry, c as one time, not again and again and again. Keep this in mind. Overall, the question is based on trigonometric property or this result, and then you will be able to integrate after changing it in this form. This was your first question. Now let us see question number 2. Try this. Question number 2. Sin x upon sin x minus alpha. Alpha is obviously constant. See, apart from x, there will be no variable. Okay. You integrate with respect to one variable, and that is clearly x with dx. Try this. Yes, anyone have any idea about second question? This question is important as well. What we can do? We have x in numerator, we can write it like this. Observing the denominator, what I have done, I have subtracted and added alpha in the angle itself. And now I will take this as a single term and this as the other term and use formula of sin a plus b. So formula of sin a plus b is sin a cos b plus cos a sin b. In the denominator we have sin x minus alpha. Now we will split it in two parts. Sin x minus alpha upon sin x minus alpha, only cos alpha will be remaining. Here it will become cot x minus alpha sin alpha. You know that alpha is constant, so terms of alpha will also be constant. First we integrated. Now let's take cos alpha outside the variable or integrand. Okay, now we integrate. Integration of 1 is x, so this will be x cos alpha. Integration of cot is log base e mod sin x minus alpha. And what is coefficient of x? 1. So no need to divide, this will be the answer. Okay. Subtract and add number observing the denominator. Let us write the third question now. 1 minus sin x upon 1 minus cos x. See, in trigonometric questions containing trigonometric ratios, trigonometric formulae are very important. Okay. And when you will learn them only, then you will identify them. Simple. So here in this particular question, first I will write sin x as 2 sin x by 2 cos x by 2 using formula of sin 2a. And in the denominator, I will use formula of 1 minus cos 2a, which is 2 sin square a. We can split this and we'll get the answer in the next step. Split this, you will get 1 by 2 sin square x by 2. In the next one, you will get cot x by 2. You will take 1 by 2 outside, differentiation of, 1 by sin square will change to cos x square. This is integration of cot x by 2. Now, integration of cos x square is minus cot x by 2. And important thing is coefficient of x is half, so question will be divided by half. That rule, if you change x by ax plus b, then appearance of the formula answer is same, but integral also gets divided by the coefficient of x. And integration of cot, this is the standard formula we just discussed. Formula will be log base e mod sin x by 2. Here also coefficient is half, so this will also be divided by 2. Finally, what you will get, this half and half will be cancelled. Minus cot x by 2 minus 2 log base e mod sin x by 2 plus c. So what I have done, using trigonometric formulae, I have changed it in standard formula. We have differentiation of cos x square studied on the last term, and different integration of cot we learned today. Okay, compare with that and then you can write the formula. No need of substitution. Why? Because integration of cot has already been derived using substitution only. That is why. Now the next question, fourth one. For fourth one, I am giving you the hint, you need to substitute something. And it is very clear, those who have paid attention in differentiation, they can tell me What will be the substitution? Who will tell? For question number 4, what should be the substitution? Tell me. Any one of you? What should be the substitution? It is clear from the question itself. Just try it. Anyone? Alicia, will you try?
I can't get it, sir.
Alright, no problem. See, you need to put root x as t. Why? If you remember, while we were studying differentiation, at that time I told you that you remember this result. Differentiation of root x with respect to x is 1 by 2 root x. Obviously, you use formula of x to the power and you differentiate it, you get 1 by 2 root x. So when you will put it equal to t and you will differentiate with respect to t, differentiation of root is 1 by 2 root. We might have used this thing so many times. Differentiation of x is dx by dt. This is one. So what you do, every one of you start solving NCRT based on today's class and yesterday's class. You can solve the first two exercises. Please start solving these things. Okay, you have not asked even a single question in AOD. I don't know what you guys are up to, but for integration you try these questions. Okay, don't wait for anything. So dx by root x is 2 dt. Okay, differentiated with respect to t. Now I'll be using these values here. Okay, in place of root x I will put t. In place of dx by root x I will write 2 dt. 2 will come outside. I need to integrate only cos t. We have standard formula for this. Integration of cos is sine. Integration of cos is sine. And now in place of t I can write root x. Okay. So the finally your answer will be 2 sine root x plus c. This is the integration. I hope this is clear. Okay, root x. Whenever you have root x in the question and you have some other term also where root x is present, so remember this, and the reason is here. D by dx of root x is 1 by 2 root x, right? Let us take the last example for today. That will be it. Fifth question. So this will basically cover the second type of questions in this chapter. The next class we will include some more formulae. I could have just simply given you a list and I would have said, see, these are the formulae learned and that's all the questions, but it won't serve any purpose. Okay. So when I am taking so much time, it's your duty that you are supposed to do the work whatever I am giving you. Okay. You will not get this time again. Now you can solve integration. You can't think about solving it 2 months later. Last question. Integration of x cube minus 1 cube root, and then we have x to the power 5 dx. Hint is substitution. Can anyone tell me what could it be? So you won't find all the questions on those four formulae. First you studied substitution. You learned that you are supposed to put something equal to t. You will change rest with respect to, you will change rest in terms of t, something like that. Then you learn few formulae. Based on that we solve some questions. But see, this particular question there is no 10 code, something like that. So it is based on some simple substitution. And this will be x cube minus 1 is equal to t or t cube. Why I am taking it as t cube and not t? Because the cube root is there. So if you will take this as t cube, it what to do next? What to do next? We always differentiate, right? Differentiate with respect to x. So differentiation of x cube will be 3x square. Differentiation of x will be dx by dt. Here it will be 3t square. We cancel it. So in place of x square dx, I will write t square dt. Let us use these values. Let us use these values. What I will write here in the first bracket, t cube, this is cube root. And what about x to the power 5? X to the power 5 can be written as x cube into x square. Okay. And x square dx. From x to the power 5, I will take x square, I will adjust it with dx, and its value will be t square dt. What else is remaining? T cube is remaining. Sorry, x cube is remaining because I have already taken x square. X cube is remaining, its value can be calculated from here, and x cube will be t cube plus 1. Now that's it. T cube cube root is t into t cube plus 1 into t square. Multiply all these and use formula of x to the power n. T to the power 6 plus t cube. We will integrate it. T to the 7 by 7 plus t4 by 4 plus t. And what you are supposed to do, you are supposed to put value of t here. For that you take cube root also. This is the value of t, and this value you are supposed to put here and here. And with this we integrate this thing. Okay. Substitution. Start by solving NCERT. It will be very good for you. First 2-3 exercises can be solved based on these two classes. Okay. That will be sufficient for you. Rest I have already provided you the notes. Go through them. Okay. That's it. Now, as I told you, our class will be on Sunday, and that will be after the test. Timing I will tell you tomorrow. That's it for today. Thank you.
Thank you, sir.